Okay, welcome back now to part 5. So just to recap part 4, I introduced the concept of a force, another name for a push or a pull. And in that exercise, I said, kind of crazy, I said, let's just pretend like there's only one force acting on something. And then you can kind of figure out what its motion is going to do. But it's so unrealistic because in every case, almost everything I can think of has multiple forces acting on it. So I'm going to show you today how to deal with a common situation where you have multiple forces acting on one object. And we're going to combine them to find what we call the net force. All right. So let me describe this in words, and then we'll do some exercises like I'm going to have you do. And you'll find this is not hard to do at all. If you can add and subtract, then you are more than qualified to do what I'm going to have you do here. Okay. So first, let's talk about the word net. A net force. It really means this. It's the combination of all of the forces acting on something. And another word for that combination is the word sum. You've heard that in math class, right? When you add things together or combine them, what you end up with is called the sum of those. So the sum of 3 plus 5 is 8. The sum of 3 plus negative 5 is negative 2, right? So you learn how to sum things together that might be positive and negative. That's going to be similar to what we're going to do with forces, all right? So I'm going to ask you in these exercises to, maybe in a picture, I'll say, find what the net force is, okay? So again, just describe it in words before I do it as an exercise. To find a net force, I'm putting net in quotes because net is just another word for total or sum or combination. It's not like a fishing net or like a volleyball net or something like that. So what you do is you find out how much more force acts in one direction than in the opposite direction. Always feel free to pause to finish writing. So now I'll show you what some of the exercises are that I'll give you and how you will do this process when you do that. All right, so I drew our first scenario here, and I'd like you to draw this too. So pause here if you need to. What you were going to draw is just a little box, and it doesn't matter. This box just represents our object, okay? We represent everything in science as little boxes because a lot of times science people can't draw very well. So if I want to draw a car, I might draw it like a box. If I want to draw a person, like me, I might draw a little box, okay? Somebody once told me I was a blockhead. Maybe that's the perfect representation of me. And what we're showing on here are 3 forces that are all acting on the box at the same time, okay? 7 newtons to the left. Oh, newtons. N. That's a unit that we use to measure force. Now, you're more familiar with the English unit of pounds. So when you say so many pounds, that's actually a force. Like when you step on somebody, however you are, maybe you're 165 pounds, that's how much force you're exerting on that person. But this force here in the international system, we use newtons, capital N, okay? So you just get used to that. So 7 newtons to the left, and we've got 2 things pulling to the right, 3 newtons and another 8 newtons. Now, I'll bet I would have asked you this, and you probably would have gotten this right, even if I hadn't described what to do. So we're going to find the combination of all 3 of those forces. And it's kind of like if you put them all together and you represented them as a single force, what would that be? Again, I'll bet I know that most of you could do this without me doing it for you. But here's what we do. We notice that while we have 7 newtons acting to the left, look at the combination of these rightward forces. 2 rightward forces together just get added together. So it's like a single person pulling with 11 newtons to the right. So then if you do that, 11 newtons rightward, but only 7 newtons leftward would combine using subtraction. See how I said how much more force acts one way than in the opposite way? So 11 rightward and 7 leftward means I have 4 more newtons acting rightward than I have leftward. And so that 4 newtons is the net force due to all of those 3. That's not so bad, right? All right, let's try another one. All right, see where I'm going with this one? Why don't you just pause it here and see if you can draw the one net force on here, okay? Give yourself a second, and then start playing again, and I'll give it away. Spoiler alert. Okay, so how'd you do? It can be a little deceiving because it looks like maybe there's going to be more force to the right because there's 3 of them there. And there's only 1 to the left. But look how big this leftward force is. Do you see that with 14 newtons here, you still have more leftward force than the combination of these 3 to the right? Because 2 plus 4 plus 5 only adds up to 11. So what do we have? We have 3 more newtons leftward than we have rightward, right? So that's the idea of a net force. Now, turns out you can have a net force in 2 different directions. Let's let our last one be one where we have 2 different directions to think about, okay? All right, so here's our last scenario. Now, the answer to this one isn't going to come out quite like you expected to, probably. When you take a class later on in high school or maybe in college, you might take a class called physics, and you'll get into a little bit more detail, and you'll know a little bit more math by then. And they're going to teach you in that class how to combine these into a single arrow, okay? And it doesn't point up, down, left, or right. But for this class, I think it's best if I let you do it in 2 different parts. So you're going to tell me how much horizontal or left-right net force you have, and separately you can tell me how much vertical or up-down net force you have. So why don't you pause here and try to find 2 different arrows, one for the verticals and one for the horizontals, and then we'll call it good. Okay? Pause here and then start replaying and we'll give it away. All right, spoiler alert. So let's look at the horizontals. You see how we got 12 to the right, but only 7 to the left? That means we have 5 more newtons to the right than to the left. So we would draw a single force of 5 newtons that way. And we have 2 newtons vertically, 6 down and 4 up, which means we have 2 more down than up. So we would separately draw a 2 newton net force downward. And it turns out in a lot of the things that we do with forces, it's really helpful to know how much is horizontal and how much is vertical. But again, some of you know, maybe from math class, if you're in geometry already, how to combine something that's 5 to the right and 2 down. Turns out it's a little bit down and a little bit to the right. But this is as far as I want to go for the net force. So I would ask you only for the horizontal and vertical parts of the net force, okay? All right, so that's the next piece. We'll give a little practice on this, and pretty soon we're going to tie this together with what we saw in the first lesson about what forces do to the motion of something. Okay? All right, I'll have to do a little practice.